So let's work on expanding. Right. And so that's kind of your key to know what we're going to be doing. So we're going to be expanding logarithms. And we're going to be using the rules above that we've previously discussed. So your rules for logarithms when you expand, some of them are going to be a little odd. For example, right, if I have log base 3, and then I have 4x squared divided by 11 y to the 4th z to the 5th. Right? And all of that is my quotient. Right? So first, I can see that I have a quotient, so I'm going to be subtracting off some terms. Every single one of these factors in the denominator is going to get a subtraction sign. So the first thing that I'm going to do is I'm going to think about, focus on the factors in the top. So log base 3. And now 4 is not a simplified number. We want to always think about, could I rewrite that number as a base to a power? So if you have the number 4, you need to rewrite that as 2 squared plus the log base 3 of x squared. And again, that takes care of the two factors in the numerator. Now, for all three of these factors down in the denominator, because they're in the denominator, they need to be met with a subtraction sign to use the quotient rule. So I'm going to have to subtract off the log base 3 of 11, and subtract off log base 3 of y to the 4th, and then I'm going to also subtract off log base 3 of z to the 5th. So right there, what that's doing is it's using the first two properties. The first property being anything that is being multiplied together could be separated out with an addition sign. And all of these do have addition signs in front of them, but because they are in the denominator, creates a subtraction sign for the second rule. Now you're not allowed to leave it that way, because anytime you have a power, right, for all of these powers, you need to bring that as a multiplicative factor out front. So that's the same as 2 log base 3 of 2 plus 2 log base 3 of x minus log base 3 of 11. And again, I need to also subtract off a 4 log base 3 of y and subtract off a 5 log base 3 of z. So it looks a little complicated, but you're just using the three rules, whichever one you need at that moment. Usually the ones that are a little bit more complicated for students, right, are the ones that have radicals in them. So for example, log base 2, I'm going to rewrite this as the square root of 4. I don't know, let's do a different number. Let's do 8. Right? So 8x cubed y. So that's all underneath the radical. And I'll put a different one in the denominator. So let's do, say, the cubed root of just z, and that's it. All right. So to expand this out, again, I have a quotient. But first what I'm going to do is I'm going to rewrite this logarithm, and I'm going to take this exponent, or this radical, and turn it into an exponent. So the 8x cubed y is all what's underneath the square root symbol. And to go backwards, that's the same thing as writing it to the 1/2 power. So square roots, you have to remember again that the denominator is the index. So the same thing here. In this denominator, what's underneath the root is z, but because of the index, change it to a 1/3 power. Okay. So that's my first step. Now my second step is now I'm going to need also a rule of some exponents. And I have to use a rule that says that if I have a power on the outside, that can be distributed to each of the powers on the inside. Right? So we have our log base 2, and that's going to be the same thing as 8 to the 1/2 power. But what I'm going to do is I'm first going to rewrite 8 as a base 2 cubed. And then when I put that 1/2 power on there, I can say 3 times 1/2 is the same thing as 3/2. So I need to, again, rewrite 8 as 2 cubed. And remember from previous examples, the cube is what goes along with the 2, but the index is in the denominator. And then I have x cubed with an index of 2 times a y, and it only gets the 1/2 power, because again, 1 times 1/2 is 1/2. And in the denominator, I still just only have z to the 1/3, because this 1/2 only applies to the numerator, it never touches the denominator. Okay. So now I'm going to expand this out some more. And I want you to notice that when we expand these out, we did it in 2 steps last time. And the second step was taking the exponent and putting out front and then rewriting exactly what we had. So I'm going to rewrite this and use the rule at the same time. So if I know that this exponent's going to need to go out front as the factor to my log base 2 of that specific base. And now because these are all in the numerator, I'm going to add. I'm going to take this 3/2 and bring that out front. And that's going to go to my log base 2 of its base. Same thing here. This is going to go out front as a log base 2 of that base. And now I'm going to consider the denominator. So the denominator has my division bar, which means I'm going to have to subtract off. And I'm going to bring my 1/3 out front, log base 2 of z. So this is what we consider expanding logarithms.